Время начинать, да? Не кричи в микрофон. Okay, so the working language is English, and the materials are a bit not so far away, but we are coming from the microscope to almost a telescope, or at least, I don't know, some, or maybe our eyes or something like this, but we are generally moving close to the public health and demography. And, well, the topic of our lecture is what if our patient is the whole population? And I will just show you some basics of demography and how it could be somehow connected with bioinformatics, bioengineering, biostatistics, and so on. And my name is Vladimir. Well, generally, I have quite a long story of employment. Currently, I'm working for Nazarbayev University, Astana. Previously, I used to work in Germany. Previously, I used to work in Moscow, and while still publishing some in demography, and also have several publications in biostatistics, well, but generally dealing with mostly clinical cases and so on. So, okay, let's go, and I hope our lecture will be more or less interactive. So generally don't sleep from the very beginning. I generally try to be very open and ask the questions. Maybe, I don't know, maybe one question for one slide or even more and so on. Okay, let's go. So, well, generally. Now we are close to demography, close to public health and so on. And I suppose that many of you just got the questions. Well, okay, we've got some brilliant results. For what purpose, generally, these results could be used? Some of the projects announced yesterday, well, they give quite a direct answer on these questions. They are generally really dealing with the problems of public health, problems of demography, but some of the topics are a bit far away. But generally I should say that altogether they are all working in case of the public health and in case of demography and so on. So generally, when we are talking about public health, we are talking a bit about demography, a bit about epidemiology, and generally how this bioinformatics help us to look at, for example, the risks that population get. And, well, generally just coming to the lecture, not to the introduction. Well, what could be the most interesting case and the most interesting indicator for specialists in demography and public health when we are talking about the well, results or the output of our system? Well, the economists, in most of the cases, microeconomists, they are talking about and discussing about the GDP. We can criticize it heavily, but still they are talking about GDP. What about the demographers and specialists in public health? Well, when we're talking about the output, the results, and so on, what is the main indicator? Death rate. Okay, but death rate, many persons don't understand what is it, death rate. And many persons don't understand what is survival, for example, survival curve, and so on. So in this case, there is one indicator that makes, I don't know, a certain simplified model, and the result is more or less interpretable. And for example, the policy makers, they understand it, they think they understand it better. So the death rate is converted into what? No, mortality, no, generally mortality, this is a process. The death rate, this is a sort of the measurement. Life expectancy, the life expectancy. There is a model that converts death rates into probabilities to die, survival curves, and so on. And in this case, finally, we get the indicated life expectancy. And the majority of the policymakers, they take a look at the life expectancy, and mainly they look at the life expectancy at birth. Yeah. So if somebody is talking about mortality, death rate, and so on, in most of the cases, they mean life expectancy at birth. So, and in this case, what should we do? If we should say that there is a progress in our public health, what should we observe in life expectancy? We should observe that the life expectancy is growing, yeah? There was a certain discussion between Vopel and Olshansky, if the life expectancy is growing all the time, if we have the constant improvement of life expectancy. And I will demonstrate here the graph, which I suppose all of you saw this graph. This is a sort of the visualization made by our world in data. And well, it's a bit tricky one because they not look at the whole life expectancy, but they look at the life expectancy for females, so the highest life expectancy. Yeah, because well, generally, if you take a look at the other graph, you will see that women generally live longer than men in every country. Well, okay, just one question, mainly for the specialists who came from medicine. Were there periods in our history when the life expectancy for female was lower than the life expectancy for male? Medieval, we don't have very good statistics, but, well, okay, in 19th century, it could be the same, yeah. But what was the reason for it? Multiple births or just the birth, or just the process of pregnancy and delivery and the birth and so on. Yeah, the problem with obstetrics, gynecology and so on. Yeah, in some countries, I remember that maybe 40 or 30 years ago, in the countries with more or less reliable statistics, like India, some states of India, Pakistan, some states of Bangladesh, and so on, the life expectancy for female was maybe half a year lower than life expectancy for male population, which was generally explained by the situation that there was still high risks to die within the process of childbearing and pregnancy as well. Maybe in Middle Age the situation was the same, but we don't know exactly, we don't have very reliable data. And don't forget that in Middle Ages, there were also some risk factors for male population, for men, like, I don't know, different wars and so on. And in this case, it was very close. Okay, but now there are no countries when there is no gap. And, well, generally, the women live longer. And you see, the longest living women are in Hong Kong, which is also a sort of the trick, because Hong Kong is, well, it's quite a small country, and maybe it's a part of China. So, so there is a certain trick in this graph, yeah, because if you don't take Hong Kong, if you take Japan, for example, a big country, the life expectancy will be much lower, maybe half a year lower. And what we can see here that, well, generally, there is a sort of the plateau here. There is COVID here. Yeah, you see, there was a spike down. Well, and then looks like that there is not a proper recovery. And, well, many persons now, many analysts say that now we are at the period of the stagnation of life expectancy. And in this case, they refer to the biostatistics, bioengineering, bioinformatics, and so on, with the questions if it's possible to do something with life expectancy. And, well, generally, maybe it's possible, maybe it's not. We don't know generally. Now we see what we see. But, well, in public health, people are thinking about this intervention. And, well, the demographers are still observing the situation and looking for the improvements, understanding if it's just, well, generally bioinformatics or bioengineering that could change the situation, or if it is something else. So, okay, but before we go next, there is another question. Do you know the countries with the highest gaps between genders in life expectancy? When the gaps is something close to 10. What are these countries? Russia, very good. Kazakhstan as well. Moldova, as a matter of fact. Belarus, Ukraine, by certain reason. The whole Eastern Europe, actually. And there is a big question. Is it bioinformatics or genetics or something like this that could explain this gap? In my opinion, no. In my opinion, no. In my opinion, this is just the behavior factors. These are behavior factors. Yeah, there were many research that were trying to explain it, because you see, the medical observation could be, the medical explanation could be quite straightforward. What people could say from medicine, how can explain the very big gap between male and female population? Mhm. Smoking, alcohol. One X chromosome explains maybe 3 years, yeah? But what about 10? So one X chromosome explains 3 years, 7 other years. Smoking, alcohol, risky behavior. And with risky behavior, we are going to sociologists because you see, the sociologists should explain us what's going on with the risky behavior. What else? So, okay, smoking, drinking, and so on. Very good. But why X chromosome is the determinant of the risky behavior? Why male are more risky? Is it possible to say that they are genetically risky? Okay, the question of broken genes, but okay, but the question for everybody. So why the behavior of male population is more risky? Evolutionary theory as well. What else? Sorry, antigens. What else? Competition for women, also very good. But why in Eastern Europe it's so huge? Why in Eastern Europe this competition for women is so huge? Why here in Kazakhstan they compete for women, or in Russia, or in Moldova, or in Poland, or in Serbia? Why there is such a huge competition for women? Well, this is a question to the social science in many cases, yeah? So there were many research, at least for Russia, for example, and so on, where they demonstrated that the drinking patterns for Russian male population was really huge and was, for example, more risky than among male population in Scandinavia. Yeah, there was, for example, Tromsø Arkhangelsk research, when they just looked at the cohorts and trying to compare the population in Tromsø and the population in Arkhangelsk. But the main reason was people still don't understand why is it so, why people drink. So of course maybe there is a problem of stress, yeah, but you know that it's not so easy to measure stress right now, yeah. It's still not easy to measure stress. But this is also the question to the biostatisticians and so on, how to measure stress well without losing the information, and so on, and without losing the whole money actually of our grant that will be given for us. So this is still a question, but yeah, we are here. We're in the territory of the Central Asia, Eastern Europe, when the gap is the highest, and looks like that it's not just genetics that explains it. It's mainly social studies and so on. Many people say that it's so-called post-Soviet legacy, but post-Soviet legacy, this is just, you see, this is just one of the variables in the model. You just put it into the model, yeah, especially if you work at it post-Soviet. It works, it's significant, or I don't know, it depends on what model do you use. Well, it's always significant, but the problem is that you should describe all the mechanisms, and this is welcome back to sociology, and yeah, maybe to some public health. Maybe, I don't know, maybe the so-called Soviet system of public health was somehow with some mutation, let's call it like this. So yeah, there are many gaps, but well, what can you see from here? You can see that, well, the life expectancy generally here in the world looks like that after COVID is not growing so fast. So okay, let's go further. Let's go further. So generally, this is if you just modify these graphs and take a look at the Japan, Switzerland, and Australia, and take a look at the both genders, and well, generally you see that, well, it's 80 something. 3 countries. It's, well, generally different. Australia, Switzerland, Japan. They are from different continents. They have different health systems, healthcare systems, and many differences. But well, generally they're still close. They're still close. And next, my examples will generally come from the situation in Japan, and also as we're here in Almaty, I will show you some examples from Kazakhstan. It will be also very interesting. And in this case, when I will talk Kazakhstan, well, it will be one of the representatives of the well, post-Soviet legacy of the high gender gap between life expectancies, very high male mortality, and so on and so on. So in this case, it's not just Kazakhstan as an example, it's Kazakhstan as a typical representative of certain group of the countries with a very good statistics, more or less reliable statistics. We cannot say that perfect because it's not in human mortality database, but very good. Okay, so let's go further. Let's go further. If we are talking about the life expectancy, let's talk about the limits of life expectancy. And I suppose that some of you know about Jean Calmet, yeah? And actually, if we go back to our previous presentation, you remember we were talking about the machine learning algorithms and so on. Jean Calmet is well known also by using different IT solutions in her case. I don't know, maybe you know somehow about this case. So who is Jean Calmet? She died at the age of 122 and a half. And what was the problem? The problem was that she was born, oops, okay, you can hear me, that she was born at the last quarter of the 19th century, that there are questions to the reliability of her birth certificates. What is the other problem? The other problem is that, well, genially, she died at the age of 222, and it looks like that nobody else lived longer than 120. So in this case, we are just going back to the other methods. And if you just type here, I don't know, somewhere in Google School or in some other journal metrics databases, you will find nowadays many of papers using, I don't know, something like artificial intelligence trying to measure the age and so on and so on. Because many persons using some advanced methods were trying to understand if she was really so old or maybe she was just younger. So this is a very interesting case that if you talk about the algorithms and machine learning and artificial intelligence and so on, very interesting. And there are, I don't know, not hundreds, but dozens of papers about it, if she was really so old. So, okay, but then we are going to the more reliable cases, and we see that nowadays, we should say that people live, I don't know, could reach 118. 116 for male population, which is generally good, but very limited number of persons from populations could reach it. And it looks like that all specialists in genetics are very interested in their combinations of genes. Okay, so let's go further. And these persons in demography are called supercentenarians. The supercentenarians, if we go back to statistics, they're always the nightmare for the statistics, because if we calculate the survival rates and the life expectancy for them, you see there are not so many of this person. And let's assume you have to calculate the life expectancy at the age of 90 or 95 or 100. And in the whole population, you have, I don't know, maybe 2-3 observations. And for example, next year, nobody dies. The next year, all of them die, and so on. Try to calculate survival curves and try to calculate life tables for life expectancy for this population. It's really not so easy. And if we are talking about the statistics in demography, there are certain specialists in mathematical demography who are dealing with centenarians and supercentenarians, trying to find the parametric models how to calculate life expectancy at the age after 90. Because you see, this is very, very rare events. So yeah, maybe for genetics, very good to take a look at the genes. For statisticians, yeah, sort of the nightmare. There are several, calculation approaches to this. But okay, let's go. Well, what we can see from the centenarians to supercentenarians, the probability to reach 110 if you are at the age of 100 is something like 0.1%. Yeah. Also, the majority of them are women, which is generally because of, I suppose, genetics, X chromosome or something like this. Oh, I don't know, generally. We should read it more carefully. I don't think that the risky behavior here plays a role. I don't think that the, I don't know, some health here, public health here plays a role, but okay, good. They could be found in a very limited number of territories. Maybe mainly Japan, France, Italy, USA, countries with reliable records and long life expectancy. So, previous time, yesterday, the previous presenter talked about the Nobel Prize. Yeah? And now we will talk not about the, Nobel Prize, but IG Nobel Prize, yeah, which is in Russian called Shnobelevskaya Premia. Yeah, because one of these prizes in biology was granted to the research that, well, had this abstract. Yeah, credibility of the regions, so-called blue zones, when there are places of exceptional longevity. I suppose that those of you who are working with, I don't know, public health and the part of public health that's dealing with the nutrition, if you're dealing with nutrition, or I don't know, at so-called risk factors of food or food consumption, I suppose you know about these blue zones, so-called Okinawa diet, the diet of the Mediterranean islands, and so on, so Greek and Italian. So generally, the question was, if in these blue zones, people live so long? The answer was, well, looks like that no. For this, they've got this Nobelevskaya Premia, which was very nice. And what I should say, you should be very careful with the data, with the results. In case of demography, for example, don't forget that in majority of the countries, we don't have reliable statistics about not just the causes of death, but the reliable statistics about the ages of death. I don't know, generally, we should go maybe 2 generations beforehand and go back to the Soviet medicine when they were talking about the super centenarians living somewhere in Azerbaijan, in Abkhazia, and so on. If you still open some textbooks in medicine, Soviet ones, they will find that, okay, the people from Abkhazia, they live as long as 150 years. Which was very nice because those of you who read in Russian, you can find in some libraries they're already digitalized. You can take a look at the digitalized data about the expeditions to these mountain places of Abkhazia, Azerbaijan, and so on, when they found the super centenarians, and as a result, they were at least 50 years younger, the majority. Yeah, so they were maybe 80, 85, and so on. So actually, there were no real supercentenarians in these territories. These supercentenarians maybe they just looked so bad in most of the cases. They were quite young. So yeah, be very careful with these results. Be very careful with this result, and especially, of course, with these diets and so on. But you see, yeah, we know that the biologist is not so easy to trick you. But for example, many economists were tricked by these cases, and I remember there are papers in economics who are talking about, I don't know, the special diet who could somehow influence the life expectancy, and in this case make people, I don't know, happier. I remember, I don't know, there were some papers by Leszek Boltyrowicz, the father of the Polish shock therapy, privatization, economic reforms, who, I don't know, claimed, looking very serious, with a very serious face, that well, generally the opportunities to get some tropical fruits reduced the cardiovascular mortality in Poland really significantly, which maybe reduced to several, I don't know, days for life table, but not so seriously. So, okay, let's go a bit further. So, okay, about supercentenarians. Well, the question is if they have specific genes, or I don't know, or maybe I don't know if they have specific conditions of living. If this, but supercentenarians, yes, specific genes. But what about the centenarians and those who reach the age of 85 and so on? If it's genes or conditions, or I don't know, some limited physical activity, well, still the question, very big question, but well, something that some of you should work a bit, or maybe I don't know, elaborate more in details. Well, so what we've got from these lessons. So the first one that already, this message was already announced previous presentation. Yeah, good data first, then good modeling. Well, in case of life expectancy, mortality, and so on, the results are, well, in many countries are good. But this is mainly the problem is with migration in case of demography, but with mortality, yeah, sometimes not just with supercentenarians, but well, sometimes with infant mortality, there is this problem. I don't know, maybe you remember this paradox of infant and child mortality that came into the Proverbs, and they came into the, I don't know, very specific collocations and sayings. There is one paradox that comes from the infant mortality. Well, if you just to show you that it's not just supercentenarians or the older population, but there is one, I don't know, paradoxical proverb. It sounds it's connected. The first time it's connected with war. Maybe all of you heard it. It's connected about the sex ratio and war. Very common saying. In Russian, it's called "мальчики рождаются к войне." This is a very interesting illustration of the of some statistical paradoxes. Because you see, there is a certain, you know that there is a certain sex ratio at birth, yeah, so-called secondary sex ratio. Maybe you remember roughly what is this sex ratio. This is 105 boys to 100 girls. If we are talking about the higher parities, maybe, I don't know, the birth 5th, 6th by order, this this ratio is a bit lower. It's also explained by some biological causes. Yeah, the situation that generally with a higher parity, there is a high risk of mortality of the embryon and so on and so on. Of the fetal death, there is high risk of the fetal death, and it will be 103, for example, for 100 and so on. However, generally the explanation of the phenomena why within war, generally there are more boys than girls. This is the following. This thing, generally could be observed previous years when the statistics was not reliable. Nobody looked at the birth records. Nobody looked at the initial secondary sex ratio. They actually looked at the certain tertiary gender sex ratio. At the age of 1, for example, or even at the age of 5, when they looked at the census or the other, I don't know, registers and the other sources of information. And here, by these registers, it was the ratio not 105, but something like 107, 108, and so on, which is strange because in reality, they are just common to each other. So in this case, the mortality between boys is higher than mortality between girls. But it's not only the wars; it's mainly the situation when there are some shock, risky economic conditions. Something happens. I don't know, famine, war, pandemics, something else. And in this case, in traditional society, the more attentions, so they have limited resources for the newborn. And in traditional societies, in the majority of them, more attention is paid for boys. And in this case, the boys will survive with higher probability. And in this case, at the age of 1 or 5, when the census or the, I don't know, revision will be organized, you will find that that this ratio is not going down, but growing. And that's why we thought sort of the evidence of this proverb that войну рождаются мальчики рождаются к войне. And yeah, one more time, this is a reverse causality. One more time, reverse causality. It's not, generally the boys are born because soon there will be war. No, this is, there are more boys at the age of 5 because there used to be harsh conditions. One of the example, war. So that's how it works. So not just supercentenarians, not just mortality at the old age, but also at the younger age. So yeah, just be careful with the data and so on. Yes, and the demographic due diligence case. So especially relevant in the regions when the registration is incomplete. I should say that in Kazakhstan, the registration is good actually. But for example, in Uzbekistan, there are many questions to the registration. And for example, when we are comparing the life expectancy in Kazakhstan and Uzbekistan and see that in Uzbekistan it's higher, in my opinion, we should generally address some questions to the statistics in Uzbekistan. Also, when we're talking about China and when we're talking about the Chinese improvement in life expectancy, we also don't know the life expectancy in China. We have very good registration system for the Chinese urban population, but not for the whole Chinese population. That's why we also don't know the real life expectancy in China. Many African countries, many South Asian countries, in India, it's more or less good. Now in Latin America, the registration is quite good. And for example, in countries like Costa Rica, Chile, Panama, the registration is even better than in many European countries. Yeah, in Argentina and Brazil and Peru, it's good, but there are some questions to the old ages. So yeah, so in this cases here, even coming from Central Asia, in Kazakhstan we know the population. In Uzbekistan we don't know the population. What is the population of Uzbekistan? We don't know. That's why the life expectancy could be there. I don't know. Could be underestimated or overestimated. We should just understand. If you just go back to Russia, I don't know if you were interested in some specific Russian regions, but there are some Russian regions when we should be very careful with life expectancy interpretation. What are these regions? In some cases, we even have so-called immortal older persons. They're not supercentenarians, but they're called Dunkelman clouds. They're called immortal in some cases. So what are these regions? One of the regions well known, many of you visited, many of you born there, many of you still live there. What is this region, Russia, with a very reliable statistics when there are Dunkelman clouds? Moscow. Yes, it's Moscow. Moscow is a motherland of Russian Dunkelman clouds. Because the person is registered in Moscow. The person receives some benefits, pensions, and so on. Then the person realized that, well, it's better to go somewhere to the countryside, to Moscow region, some neighbor regions. But the person goes there, happily dies there, comes to the death registration of the Moscow region, or I don't know, some neighbor regions registers, and, well, in Moscow, the person is still alive. In the Moscow pension fund, no. But the problem is that the Moscow pension funds is not synchronized with, for example, some household registers. And for example, there is a census organized. But in the census in Moscow, the person's organized very inaccurate. And they take the same data from the household registration. The person is still alive. The person died, I don't know, maybe 5 years ago in Moscow region, came through the Moscow region statistics, but in Moscow population pyramid, the person still exists. And the person is more than 100 now. He is, you see, Moscow Dunkelman cloud. The same was observed, for example, in Germany for the Turkish migrants when they came to Turkey when they were quite old. In Moldova as well, actually, there were some persons who used to live somewhere abroad and died there, and also could be double found in the registers of Moldova and the other countries. So yeah, but Moscow Dunkelman cloud, there was a certain paper about it. And okay, there are some other regions when the life expectancy is really high because the denominator is not calculated accurately. These regions are close to the territory when you could expect Highlanders live. So, what is the name of these territories? It's not Altai. Where are the mountains in Russia? Urals, very good, but it's not Bashkiria. Where are the other mountains? Caucasian regions. No, I thought it's not Altai. Okay, and maybe which republics in particular? Eastern Caucasian republics or Western Caucasian republics? Eastern. So mainly Dagestan and Ingushetia. Two regions when the life expectancy is higher than in the Netherlands, for example. And for women, if you use these regions, well, I suppose that for female population, they could outnumber Hong Kong. The problem is that the real population and the census population of these regions is very different. The real population is much lower, and well, is much lower, and the real life expectancy is higher than in the majority of the Russian regions. Yes, it's higher because people smoke less and drink less there, but generally it's not so super high. Yeah, so one more time, be careful with the special data. And one more time, if somebody will tell, okay, in Uzbekistan, the life expectancy is higher than in Kazakhstan, you should say, be careful one more time. We should look at the whole database. Okay, so for example, this is, you see, don't use it. This is just an illustration. I just made it randomly. So let's assume this is the quality of data registration, and this is, I don't know, the supercentenarians. So you see, the regions with the problems with registration should be here. The regions, well, when there are no problems with registration, will be here. So it will look like this. So the poor are the data, the high is the number of persons in some exclusive conditions, who are living too long, and so on. So, okay, one more time. If you just go to the public health, one more time, let's assume that we in demography have very good information, that our registers works good. And now, if we go to the public health, and some of the projects are dealing with this, first of all, we should think about the resources, yeah? So we should think about the resources, and we should understand which groups are vulnerable, yeah? I suppose you remember this equation, which is generally, one more time, this is also a style equation, because sometimes you have 4 parts of this equation, sometimes you have 5, sometimes you have 3, and so on, but it generally says biology, behavior, population contests. And in population contests, there is also the public health in many cases. And many specialists say that the biology is responsible for 15%, which is generally now, when the life expectancy is stagnating, it's quite huge. 15% now is quite huge. Well, for example, this one, genetics, behavior, social environment factors, and healthcare. This is so-called World Health Organization, or MAMAT, actually, equation. So healthcare is responsible from 10 to 15. Genetics also from 10 to 15, which is, well, quite good. So in this case, we should say that biology plays the same role as the public health, which is interesting. Okay. First of all, what we have from the literature. Early in life, genetics has a strong relative influence, and it looks like that one of the group projects are devoted to it. Yeah. What diseases, with what diseases we are dealing with, which diseases are really important for public health when genetics early in our lifespan is really important. If we don't speak about the orphans, orphan diseases, very small diseases, if we speak about something really important for the public health. So, where genetics is really important. The question. Okay, can we say that, for example, genetics could be important if we're talking about the obesity at the young age, or no? Yes, what else? What else? What else could be important? So what are these diseases that could not be so easily controlled by public health, by vaccination, for example, and some other routines? So this is one of the tasks, actually, to identify what are the risk factors that could not be controlled by the public health. Because we used to think that public health controls, I don't know, by vaccinations and so on, the problems at the younger age, but now we understand that many diseases in the younger age, they go with us within the whole lifespan. So in this case, of course, genetics is very important here. Then the situation that, well, the proportion of variation explained by genetics tends to decline with age. I agree with it or no? So in this case, previously there was also this idea that the persons who were genetically weaker, they just have lower survival rates. Looks like that now with the development of the public health, it's not obvious. Yeah. Also, we should understand what's going on. Okay. We should understand how it is modified right now. It's also the question to the biology, biostatistics, bioinformatics, and so on. So then, well, we should say that genetics loads the gun, environment pulls the trigger, age determines how fast the bullet moves. So there are at least three stages here. Yeah, at least 3 stages. Yeah, for example, it is diabetes and so on. So yes, assume that, I don't know, the situation, how severe will be your diabetes, is preoccupied by your genetics. But actually, there are many factors of behavior and so on. So in this case, yeah, it's very interesting case. The same is, for example, for breast cancer and so on and so on. There are many literature about it, and in public health, it's extremely important, and so on. So, well, and in this case, we are generally going to the causes of death right now. Now we are generally moving to the causes of death. This is Japan. actually. We are talking about Japan, the country with one of the highest life expectancy. So you see, previously it was pneumonia that was very important. Yeah, before the antibiotics. Then cerebrovascular and heart diseases, especially here, cerebrovascular diseases and heart diseases. It was before the sanitary revolution, before the so-called cardiovascular revolution, when, I don't know, the blood pressure was easily controlled by quite cheap pills and so on. Then there was cancer. Then there was certain cancer, malignant neoplasmoids. Here you can see in the graph, these are malignant neoplasmoids, and there is so-called cancer revolution. The situation when, for example, people don't die because of the cardiovascular mortality, they die due to cancer. Also, you see there is a renaissance of pneumonia. The older persons are fragile, and in this case, you see, in epidemiology, they should die from something. They don't die because of the cardiovascular mortality, because of genetics, because of, I don't know, some nutrition, because of the better health care, but they should die of something at the age of 100. Okay, let's assume they caught cold and with their fragility, they got pneumonia very soon. And take a look at this case. This is so-called senility. I should say that in our case, in case of, for example, Eastern Europe, senility was so-called methodological garbage. It was a garbage code. If you don't want to quote, I don't know, any course if you want to avoid, I don't know, the downturn of a KPI, in this case, you quote something, I don't know, like cancer or something that you should decline in senility. But here in Japan, it's really something close to senility. Looks like it's not a garbage code. So people even don't die from pneumonia at the age of 100. They should die from something. So something like, I don't know, polar organic cases and so on. So this is how very old society looks like. How the very old society looks like. They die from cancer, they die from senility and so on. In this case, maybe genetic could help us a lot, and we could take a look what's going on with them. And this is the same. This is Japan, and take a look at each age. What are the main causes of death? Yeah, of course, Japan with its certain with, I don't know, the most important part of Japan. You heard a lot of the suicides, yeah, but these are only for the younger ages, and I should say they're not so high actually. But you see, so the cancers that go on, and then this is the so-called senility, old ages. So yeah, this is how it looks like. The mortality by causes of death for Japan. And here, in many cases, there are some causes that could be prevented by some advanced genetics, genetic passports, and so on. Because you see, the cardiovascular mortality is more or less controlled. So yeah. Then let's go to Kazakhstan. This is one of the papers from Kazakhstan that was recently published, and we will just get some illustrations from it. So this is the population and mortality pyramid from Kazakhstan. 2022, but in 2022 there was some echo of COVID actually in the very beginning. That's why it's not very pure table. In 2023 it could be without the effect of COVID. Here there is certain effect of COVID. So this is just the gray. This is the population pyramid of Kazakhstan, and this is the mortality pyramid, which is generally well. What is the problem here? The problem here is that we have absolute numbers. Of course, the risks to die and the standardized death rates at the older ages will be higher. But here we don't have so many persons at the age of 85 plus. So in this case, there are not so many deaths here. Okay, maybe for women, yeah, this is the highest number of deaths. For male, there are just not so many males to demonstrate the deaths. You see, these are the absolute figures, absolute. So be careful with absolute figures. In demography, you don't take them. In demography, you should take a look at the risks or at the coefficients. So, good. But what can we find here? Here we can find very interesting for the demographic and public health projection indicator, the model age of death. The age of death when generally, or the maximum age of death is also very important here. The age of death when there are the highest number of deaths. And you see that in Kazakhstan, also because of the population pyramid, This is 60, 64 for males. For female, 85 plus. This is another indirect demonstration. But one more time of the gap in life expectancy. But one more time, be very careful because there are not so many people at the age of 75. Okay, let's go further. This is seasonability, and you see these are COVID waves. So in 221 and in 220. So in 220 July and 221 August, yeah, and also May, April. The strongest waves of COVID. Here they are. Why I don't like the summer waves? Because in summer waves, sometimes they are overlapping with the heat waves. So, for example, when we're talking about Russia, there was an overlapping of the COVID wave in the Urals in 2020 with the heat wave in the Urals. And it was not so easy to distinguish them from each other. In Kazakhstan, I don't know about the heat waves in 2020, 2021. Maybe the colleagues could just say that there were also overlapping of the heat waves. Maybe yes, maybe no. Yes, please. What are the heat waves? Huh?
Like summer effects when residents come in and physicians go to the vacations.
Yeah, but okay. Okay, but the residence effect is not so visible on the other graph. But you can see somehow the answer was that maybe there is a residence effect when the residents come in, the physicians are going to the they're going to the leave. And all, but it looks like that it could be observed here. I should say that in the majority of the northern hemisphere countries, the peaks are in the winter months because of the influenza waves and so on. So these are, well, generally they're not explained by heat waves. These are just COVID waves. You can find them in many countries. Yes, please. Okay, yes. So in this case, the solution, let's take a look in 2023 and indicate the heat waves. That's very good. So yeah, let's compare them with the real heat waves. And also there are some sources of data when, for example, the heat waves in France is compared with the COVID wave in France, and so on. Okay, and also, this is the causes of death. Please take a look at the some called other disorders of the brain. Very interesting case. So, and there are comparisons. We are comparing 2014, it's here with 2022. So previously, this course was on the 13th place. It wasn't even in the top 10. Now it's in the first place. In 2022, it was in the first place. This is the classic example of the problems of the coding. What is the reason for it? We don't know. We are just demonstrating. But this is the question not to the genetics, because nothing could be changed within 8 years with the population. This is not the question to the public health, it's not public health, but healthcare system. This is just the question to the coding. Something is happening in the coding procedures. So in this case, we should take a look what's going on, because this is really shocking. Other disorders of the brain. It's not strokes, it's other disorders of the brain. Actually, no autopsy you can find other disorders of the brain. This is a brilliant example of the methodological garbage. In Russia, there were, for example, endocrine diseases that skyrocketed in some regions 6 times. Yeah, here as well, diabetes mellitus, inflammatory heart diseases. Okay, let's assume. Yeah, okay. Let's go further. Let's go further, but this is a very good example. So I took it from this. I should say that it's not just the problem of Kazakhstan, it's a problem of many countries when something is changing the procedures of coding. And you will see these examples. But as we are here, I'm just showing the local examples, okay? Something was changed, and we should understand what's happened. Okay, and this is the age standardized mortality rates by region in Kazakhstan. So here you can see so-called, in Russia, there is a northeast gradient. In Kazakhstan, there is a north gradient, or also maybe northeast gradient. Is it the problem of genetics? Is it the problem of biology? Is it the problem of climate? Looks like no. Looks like no. But here I can see Actually, there are two spots, three spots where there are the problems of registration. Astana, Chimkent, Almaty. These are the problems of majority of the countries when, for example, the quality of medicine in capitals is better than the quality of medicine in the regions. We have reasonable doubts that many deaths by some very strange or severe cases were sent to the clinics of Almaty and Chimkent from the regions. And in this case, we have higher registration in Almaty and Chimkent than in comparison with Almaty region and Turkestan region. This is very, very classical picture. It's not because of the, I don't know, you can say that it's maybe ecology, maybe the pollution in the cities and so on, but these cases looks like the situation that the more severe cases are sent. Or maybe the registration of the suburbs. Why? But you can ask me, why it's not the same in Astana? Why it's not the same in Astana? Is it the problems of the suburbs that, for example, people, I don't know, maybe a registration of death is where they live and they live in Akmala region, not in Astana and so on. Or maybe this is a problem of the denominator. Actually, we don't exactly know the number of persons living in Astana. Well, another questions that the answers we should understand. But what about this? What about this vector? What do you think is the reason for it? If we just don't care about the capitals, if we just calculate the average for the capital and the neighboring region. Exactly the same as for St. Petersburg and Leningrad region and Moscow region. I told you about the Duncan MacLeods. I suppose the same Duncan MacLeods could exist somewhere in Astana as well. Why not? Okay, but if we assume that, well, generally we calculate the death rates here for the whole region and take a look at the vector. Why there is this gradient in Kazakhstan? Why in northeastern parts of Kazakhstan the life expectancy is lower and the age standardized mortality rate, which is generally close to life expectancy, it demonstrates the intensivity of mortality, not taking into consideration the death structure is standardized here. The death structure doesn't pay any attention. We should not pay any attention on death structure. The structure is adjusted. It's the same here. So it's not because of the difference in age. This is just the high intensivity of mortality. What is the reason? Yeah? Sorry? Okay, so you bet to the cold waves. Okay, let's buy it. And or alcohol. Or alcohol. So either alcohol or waves of the cold. So cold waves, so called. Well, for cold waves we will see, because it looks like that the heat waves could be more dangerous than the hot waves, but nobody tested this hypothesis on the country with a very continental climate like Kazakhstan. We should test it. But with alcohol, I can buy it, because if you take a look at the alcohol consumption, the map for alcohol consumption looks close to this. In this case, I'd rather say religious, yeah? The religiosity, maybe it's higher in the southern part, and in this case. So the explanation is the same why ceteris paribus in Russia, for example, somewhere in Dagestan and Chechnya, even taking into consideration all problems with statistics, the life expectancy will be higher than, for example, somewhere in Arkhangelsk or Vologda. People just believe stronger and they follow the recommendations coming from their religion, and they don't drink alcohol. They use some other methods to, I don't know, not so dangerous methods to entertain themselves. Let's call it like this. Also in the social structure. Single man, you see, the problem with a single man should survive to their singlehood. Single man should survive to their widowhood. If the gap in life expectancy is 10 years, the male widow at the age of 70 is quite a low phenomena. lowly registered phenomena, well, unlikely registered phenomena. But if you convert it into the family ties, I can say that, yeah, maybe if the public health is not so good, and if the social support is not so good, the family ties could generally support, for example, the people, the older persons living in the families. Families are just looking at their habits. I don't know if they consume prescriptive pills and so on and so on. The family control. Yeah, yeah. Yeah, maybe the family control in the south, the family extended, and there is more control for the older persons. The older persons, I don't know, take prescribed pills. There is lower risk that they will go and fall somewhere and break, I don't know, their hip and so on and so on. Okay. Yeah. And another question. Here, this is Semipalatinsk. You mean radiation, yeah? You mean some of the effect of radiation, but actually there were some resources, if I'm not if I'm not mistaken, there were some resources about districts of Semipalatinsk. There are some resources that could be taken to the research, and there was some research. I'm not sure if there are real publications, but I see some preprints about it. I know that there are resources that they could distinguish these districts within the Semipalatinsk region. Which is called not Semipalatinsk, but Semir region right now, yeah? Because Semipalatinsk regions was a bit different. It was solid region that has different shape, actually, here. Okay, good. And in Karaganda, you can also, in Karaganda region, you can also say that people will work in quite risky conditions. They've got some professional diseases and so on. And in this case, it could be comparable with the Russian Kemerovo region, or I don't know, Norilsk, or some other regions and so on. Okay, good. This is close to the occupational health. Okay, good. We already discussed it. And this is a very interesting map, but please don't use it, because here we don't standardize for age. This is just natural growth. But this map depends on the population structure. It depends on the population structure. Here the population is just older in the north. And you see, one more time, the population is older with the higher risks of death. That's why here, of course, we observe very intensive decline of the population. So yeah, maybe it looks nice, but use it very carefully. Don't use it professionally, okay? Don't use the maps like this professionally. But yeah, looks good. Looks quite good. And generally looks close, actually, looks close. But looks close just because by incidence, the territories with the older populations is the territories with more vulnerable population. In Kazakhstan, in Russia, for example, is not the same. In Russia, for example, the territories with younger population, with Far East, they demonstrate the higher mortality rates standardized. So for Russia, this map will work somehow, but not exactly very good. Well, of course, there are some regions like Smolensk, Pskov, and so on, when you see both, like in Kazakhstan, north, all the population with high risk of death. But in Far East, it will not work. Yeah, and well, maybe there is a question about the consanguinity in Central Asia. Well, it's low here. It's very low, and in this case, we shouldn't care about it so much. That's what the literature tells us. But I read some literature, but only in Russian language, when they tried to compare, for example, ethnic Kazakh and ethnic Uzbek, because in ethnic Kazakh consanguinity is forbidden, and ethnic Uzbek it's not forbidden. But I found this literature, I found this cousin's marriage, yeah, consanguinity. But I found this literature only in Russian language. I didn't find the literature about the region in English language and in high-ranked journals. So according to the high-ranked journals, there is no such a problem in the whole region. Well, why it is important? Because of this paper, but there is another problem with this paper. It's published in what? It is published in, it is published in Economic Journal, American Economic Review. Very high rank for economists, but, well, the biologists could have some errors with it. So this is a well, paper that tells the dangers of consanguinity. Well, yeah, but one more time, published in Economic Journal. So in this case, maybe for the natural science, it means nothing. And this is from the National Science, the genetic structure of Kazakhstan, something like if it, make something like genetic passport and so on, what we should take care of. And, oh, sorry. And I suppose that now we can stop. Ate almost the whole time, but if you have some questions or maybe some questions for discussion and so on, we can talk about the bioinformatics perspectives in the public health, because you know how it's well, difficult to sell your ideas to the public health and so on. But well, generally, I suppose maybe some questions for discussions, some questions for me, and so on and so on. We have 5 minutes, yeah, something like this. And what about the headphones? Should I take them on? Yes, no. Headphones? No headphones. Okay, so in this case, just questions. Or maybe there are no questions because I already asked them within my presentations. That's why people already answered, got the answers. Were answered by, okay, please select.
Show the slide of the Japanese.
Yes, there's a slide about, there's a question about the Japanese causes of death.
Yes.
Yes, please. I'm showing the Japanese causes of death. This or this? Okay, this one, the Japanese causes of death by age. This is percentage distribution. Be careful.
You mentioned that in case of older straits, older cars, we can think about some genetic causes, some bioinformatic methods to.
We can think about methods, yeah, talking about the old ages.
If there are some genetic predictions of longer life, but from ethical point of view, doesn't work. Is it worth considering do these people in the age of 95, 100 really want to live
the question
for
is,
some
yes.
other 5 or 6 years?
The question if 90 plus centenarians and super centenarians really want to live. Yeah, the ethical questions, that's why this is a question to the psychologists and philosophers and the ethical commissions. I will get answers from economics. I will get. I will take the answers from. Just don't get the answers from them, but I will take these answers and try to give them for you. I don't get the real answers, but from the economic point of view, there is a very a very cynical approach that these persons don't contribute into GDP by producing the GDP. However, there is a question if they contribute to consumption. They don't contribute too much in consumption, and in this case, maybe from the economic point of view, there is not worth to invest too much money into their survival to the extra year. On the other hand, if we are talking at the age of 85 and 90, and if we go to the quality of life, if these persons are healthy, if we started to look after them a bit earlier, if they're healthy, the one additional month of them living in the healthy life, it reduces the burden of the households and the government on them. So in these cases, we should make this optimization equation. We should make this optimization equation. So if the investments in the quality of life and the quality of the healthy life of this person are generally reducing the possible time when they live in their disability. Yeah, and this is a very economic question. Then there is another question that comes also to economics, and when we're talking about the non-market produced goods and services. Many of these person, and it's not like Russian babushka phenomenon, no babushkas exist everywhere, grandmothers exist everywhere. Many of them, even at the age of 85, they still take care of their either grandparents or partners. And in this case, it's also additional burden that's taken by them. They don't work in the market, but they give some non-paid services to their households and so on. And there is also a sort of the dilemma. if it really contributes to their health or if it reduces their health. In Europe, for example, when we work with so-called share database, there are several papers about it, and they try to use this to solve this optimization task. So this is a question not just to the ethics, but to economics at least. Yeah.
So does anyone else have any question? Please raise your hand if you do.
Yeah. Okay, the question, don't mind if I'm repeating it because it's for recording, okay? Starving? This one. Distribution life expectancy in Kazakhstan and famine, you mean, starvation? Famine. Famine that took place 90 years ago, yeah? Uh-huh. Uh-huh.
Maybe religious tradition may be really beneficial for people. And for example, if Russian would follow their tradition, I mean, Orthodox tradition, they would increase their life expectancy also.
So one more time, religiosity, you mean? Yeah. Okay, good, I got it. You mean fasting? Okay, I've got it. Okay, if fasting matters. Okay, very good questions. Mm-hmm. Mm-hmm.
They had problems with food.
Mm-hmm. Okay. Okay. Okay, I've got this question. Looks like that I've got a question. You're asking about actually two sub questions. Yeah? One, the role of nutrition in this. So first one, religious fasting, and then the starvation at the youngest age. Okay, good. Okay, very good question. For Kazakhstan, the problem is not the problem. Thanks God, the starvation was 90 years ago, and in this case, the persons who genuinely starved, they already died. Yeah. However, if we look back to the situation in Netherlands, in Okinawa, in Russia and Ukraine, for example, with the great starvation and shortage, it shows that the persons who were, who were under the risk of the starvation, they really live longer. Actually, if I'm not mistaken, definitely they have higher risks of the stomach cancer. In Okinawa, actually, there was stomach cancer risks and so on. And because they have to eat some fermented food in their childhood. In Kazakhstan, we cannot say it about the starvation because starvation 90 years from this period and the majority of the person already died out who were under the starvation. But Russian and Ukrainian cases, Netherlands cases of the great starvation of 1944, Okinawa case shows that it matters. About the religious fasting. In Kazakhstan, we should get the data by the days and take a look if, for example, the fasting really matters. Because in Russia, there were also some preprints and something in Russian language when they try to take a look if the fasting in Islamic regions like Dagestan, for example, and so on influence mortality. Because there was one hypothesis that when people have fasting and then suddenly they start eating normally, many of them eat too much. And if they have some chronic disease of pancreas or stomach and so on, there could be a sort of peak of mortality just several days after the fasting. In Kazakhstan, it's something new. If the colleagues will get the day's mortality in Kazakhstan, they can take a look at it. They can take a look at it if the fasting matters. I should say that for the non-Muslim population, there were certain peaks of the, let's say, national or bank holidays. If they're too long, the mortality is going up because people drink quite a lot. In Russia, for example, in the very beginning of January, there is a spike of mortality. People drink 1 week. It's too long. In Kazakhstan, I didn't observe it. But let's see. For fasting, if you get daily data, please take a look. Please compare Muslim, non-Muslim regions and find the answer to this question. I actually don't have this data, that's why I cannot answer this question. Thank you.
More questions? Then there's a question. Could you just show us the diagram of mortality per month?
Mortality, this one, yeah?
Yeah. Don't you think that there is a small October peak, or not, or is it just my brain tricking me? No, just at the bottom.
At the bottom,
Yeah.
October peak. Actually, I don't see, because you see, actually, I see it for 2021, yeah? Well, generally, the question to the epidemiologist, I don't remember, October 2021, the end of the, was it flu or what could it be? Or was it a new wave of the COVID? Looks like that not the new storm. I'm not sure. Actually, it existed but it looks like that everywhere there is a peak in October. Looks like that it is obvious for all the years. You can see it. Well, maybe cold season and so on. So you see, actually in October we always have a sort of the growth. October was very good in Catholic countries, but not because of the mortality, but because of the fertility. Because in January is the end of the Christmas fast, and in October the growth of the fertility in Catholic countries, and in Christian Orthodox as well. But here, well, you can explain it. Actually, we didn't. You see, here we see just the visual analysis. We did not make a real good statistical analysis for it.
Yeah, it's maybe just good.
It is. Let's see. Let's see.
Right, so we're ready for the next question. So I think all the questions were answered during
The questions are over. Thank you.
Thank you very much.